Welcome to Lesson 4 for Section 7 of the BJCP training program from the Brewers Anonymous Homebrew Club. We are continuing to look at the very important brewing ingredient of water. And specifically in this lesson, pH. It's a key aspect of water that affects flavor, efficiency, clarity, and yeast health in the brewing process. So let's get started. To start off with, let's take a look at those two letters, pH. It stands for potential of hydrogen. And that concludes this lesson. Thank you for watching. I am kidding, of course. There's more to discuss. Let's start over again. Again, pH stands for potential of hydrogen. It's the scale we use to measure how acidic or how alkaline our water is. The scale for this measurement ranges from 0 to 14. You can probably guess, and guess correctly, that 7 in the center of this measurement is for a neutral pH balance. Perfectly balanced water has a pH of 7. Now, here's where the fun part of the scale comes in, and I have fun in quotes in my notes that you can't see, and here's why I did that. The more acidic the water, the lower the pH number, and that has taken me a little longer than I'd like to admit to get a handle on. To me, a more acidic liquid is more intense than a more alkaline liquid. My mind equates the intensity with a larger number, and that's obviously not the case here. In this case, when it comes to acid in water, literally less is more. The lesser or lower the number, the more acidic. So with that being the case, naturally, the higher the pH number, the more alkalinity there is to the water. And now we know why we care about that from our last lesson in alkalinity. In most brewing scenarios, again, exceptions to every rule, but in most brewing scenarios, we want a pH range of 5.2 to 5.6 for our water. This helps create a favorable environment for alpha and beta amylase enzymes to convert our mash starches into fermentable sugars. It also promotes the best extraction of polyphenols from malts and isomerization of hop alpha acids. It also promotes efficiency. This pH range keeps the grain husk from degrading and lets more of our wort through the grain bed and prevents excessive tannins and harsh flavors. Brewers try and often succeed in altering their water to hit this 5.2 to 5.6 pH range when the milled malts are added for the mashing process. Now, how that's done is a much broader subject and not one we're going to cover here. One, because this is not a water chemistry training program. And two, we luckily don't need to know that amount of detail for our entrance exam. Is some very basic chemistry we can discuss in this lesson. Once mashed in, a brewer may measure their mash's pH to make sure it's in a desired range. When the number is higher than our range, the hydrogen ions need to be raised to drop that number. A common acid addition full of hydrogen ions used to lower pH is lactic acid. Conversely, if the pH measurement reads lower than our target range, the brewer needs to raise the pH by adding more hydroxide ions. A common alkali used in brewing to raise pH is simple baking soda. Now remember the very first thing we learned about alkalinity. Alkalinity is the water's ability to resist changes in pH. When we raise the pH, we're making it more alkaline, so we don't want to overdo it because we then made it a little harder to bring the pH back down if we've raised it too high. So when raising pH, it's probably best to do a little bit at a time and keep measuring until you hit that range rather than trying to make one random guess of one dose and overshooting. To wrap up, I'm going to point out, like with everything, and I did mention this earlier, there are exceptions to every rule, and pH range is no different. For example, lightly crisp lagers benefit from a slightly lower pH than our 5.2 to 5.6 range. Darker, rich, roasty stouts benefit from a higher pH. But for our entrance exam purposes, 5.2 to 5.6 is our pH range. Acid lowers pH, alkalis raise pH, and in some ways, this part of the subject is really that simple. And on that is it for pH. Two little letters that actually mean a lot when it comes to our brewing. Let's move on to some more about water in our next lesson. I'll see you there.